So guys, in this platform, we are going to focus on our differential equations. Remember, this is another part that you're going to need in your paper one, working or solving the differential, as we can see as equations. That means there's a solving part that we are going to need. So these differential equations are simply mathematical statements that we can consider that resemble a state of equilibrium. That is where one of the terms is a differential coefficient like that. So as you're working with the differential equations, you're going to need to understand the rates of change. There's a part of the rates of change that you need to work on. Also, the separation of variables, how to separate the variables. So you're going to talk of the separation of variables. And also, you need to understand the solution by integration, meaning to say you need the basics of your integration, which we are going to talk about that as for A level, but I think guys, you've worked with that part from other videos of the netted, which is the N1. So N1, N2, N3, up to N6 there. We think there's part that is with the integration. So you just go through also your integrals, the basics of your integrals. So what you're going to need is definitely the formulation of a statement involving the part that you are given. So the concept on this part of the rates of change that we talk about is the derivative that we are referring with respect to the time that you are given. So remember, when you're dealing with the rates of change, you're working or you are actually focusing on the rate that is used to describe the change in one variable with respect to time. So one variable is related with respect to time. So one variable is related with respect to time. So in this case, it is going to be with respect to time. One variable that you're given with respect to time. So as we are referring to the differential equation, meaning to say the variable we're talking about, the derivative. So as such, we can talk of the rate that influences the change in volume. If it is the change in volume, that means the dV dt, the rate of change of volume. You are given the rate of change in area, that is the A, the T, the rate of change in terms of the radius, whatever that you're given, in terms of the time, whatever that you're given is supposed to be affected with respect to the time. That is the concept that you are going to need with respect to the time. Also, we are going to need the part of proportionality in actual sense. Okay, that's another part that you need, working with proportion. So as we do understand that the part of proportion is simply, this is our O level, guys. Those variation, talking of the variation, direct variation, inverse variation, joint variation, where we are saying this varies with this. So that is the proportion. So you'll be given direct proportion, inverse proportion, depending with what you are given. So that is the part that we are simply talking about. You can expect work with a direct. It can be an inverse. It can be a joint. Remember all those variations that you had in your O level. We have the variation sign that connects the two, then the introduction of the constant. So maybe you're given, maybe it is, we are given maybe the rate of change of length, the rate of change of length, meaning to say is the rate of change of length with respect to time. Then we are given is directly proportional to or inversely proportional to. So if it is proportional to, that is varies to whatever that you are given, which might be in terms of L or in terms of time. So maybe it is proportional to 3L squared. You're given is proportional to 3L, whatever that you're given. But you must understand the variation concept from your O level, that whenever there's a variation sign, we are supposed to remove the variation sign and introduce what? And introduce the constant. You must introduce the constant depending with the constant that you're given. Sometimes you're given to use a constant M, the constant P, it depends with what you're given. So you work with that proportionality. You must understand the variation, then the separation of variables. It's when you are solving now. This is another part that we're going to talk about when you are now solving this. So you're going to see that the process approach to the differential equations consider just little steps. One, you're going to talk of the formulation. So the steps that you need to formulate. So we have got the formulation of a dE, which is the differential equation that you're given, using whatever combination that you're given, any sort of combination. So this can be from a rate of change. It can be from the proportion that we talked about. It can be from the proportion that we talked about. It can be any sort, any combination that you're given. Any combination, maybe it's just the product of two terms that you're given there. You need to formulate the differential equation. There must be an equal sign. When there's a proportion, that's where we have to introduce the constant which goes together with an equal sign, because this must be in an equation. So by forming this, you need to solve for the constant. Whatever that you're given, there will be separation of variables that you have in that case. Let's say we are given a proportion. When you are given a proportion, you need to calculate the constant where for a proportion. You must solve for K. Let's just save this one because it's going to depend with what you're given. Solve for the constant. Solve for the constant. That is, in case you are given conditions of this case, when given conditions, so here, just work with the given conditions. Or use, just the basic part, guys. Use the given conditions. So you must use the conditions that you're given there. It's going to depend mostly for this proportionality and the rate of change. Depends, guys. We're going to talk about that as we solve. Then also, we're going to need to solve by separation. So you need to separate the variables. So we talk of the separation of the variables there so that you can be able to integrate. So that you'll be able to integrate. So in the integration, you are integrating or you are working with both sides. Remember, when you are separating variables, you are letting the part of y to be with y. You are letting what is of x to be with respect to x. With respect to y, these terms are supposed to be of y. With respect to x, this must be of x. That is to separate so that you'll be able to integrate both sides with respect to what you are given using any relevant integral technique. That is where our integration now plays a role. So using any integral technique that you can have, you need now to consider that part. So on integration, you form, or you're going to have the constant of integration. There was a constant that we had before. This one is the constant of integration. Remember your integration, guys. There's a constant that is formed. We can just say the constant of integration C. So obtaining the constant of integration from the right-hand side of your equation, you must solve for that constant. We must solve for C, which is the constant of integration, using the initial condition that you are given. Remember, you'll be given those initial conditions that you had before. So in calculating of the C, you use those conditions. But if you are not given any condition where you can calculate the C will represent the general, so where the C is, that equation will be the general solution. But the moment you calculate your C and have it in as now the particular solution that you're now having in that case. So in that case, you can solve for C. In this case, remember C is the constant of what? Integration. I'm going to talk about that. And also, thereafter, just solve whatever problem that you're given there. If any exist, if you're given anything, you can solve any given equation or thereafter, any given a problem, or just say equation on any of the given problems thereafter. So meaning to say, with these steps, guys, we can have formulations. So like I said, we just need to understand the basics. So this part, we are actually going to work with it as much in the simplification that we are going to have in the later questions, actually in later questions that we are going to have. But just for the basics that you need, just for the basics, this is what you will need on solving of the differential equations or working with the differential equations. Like I said, we will work with separate exam questions. But for now, I want us to just consider these first order differential equations. Remember, we talked of the separation here of variables. It is something about the separating part of our variables. That is the part that I want us to talk about. Then solving, we'll see if we're going to have time work on a different class where we use question papers. That part is best for me to explain from question papers so that you understand the applications of what I was explaining on those steps. All right, so like I said, we're going to have first order differential equation, separation of variables. So we're going to talk of the separation of variables. Like I said before, to separate variables, it simply means what is of X is supposed to be with X and what is of Y is supposed to be of Y. So mostly we're going to have this, the Y on the left-hand side, whatever way that you are given in terms of your question. But this is supposed to be of Y, this is supposed to be of X. Maybe it is X with exponent of 3, it is Y to whatever that you're given. It is a trigonometric expression that you are given the cos of Y with respect to Y. Whatever that is of X is supposed to be with respect to X. So that is the case. So how to separate and integrate thereafter? That is the process. So let's consider we are given a condition like Y dx is equal to X. And you're asked to determine the general solution. So in this case, let's try to determine the general solution. That is the general solution. All right. So to separate this, so guys, this is just a division. So you can even cross multiply like over 1. You multiply this, that's Y dx is equal to dx multiplies, that's Y dy here, sorry. That's Y dy is equal to dx multiplies x, so that's x dx. As you can see, we've separated. The part of Y is on its own, the part of X is on its own. So once you have got this, you are going to integrate both sides. So in this case, integrate both sides, like I said before. So let's integrate. Remember your integral, guys, like I said, this is 1 on its own. When you integrate, remember you're supposed to add a 1. So that is Y to the exponent of 2. Then you divide by the new exponent, the new power. You add 1, you divide by the new power that you're given. The same on X, this is 1, you add 1, so that's X to the power of 2, divide by the new power, which is 2, plus the constant of integration. So that's it. So in later sense, you'll see that sometimes you avoid working with the fractions, but there is our constant, and we can even multiply, let's say multiply by 2, and this by 2 here. that is going to give us y squared is equal to x squared plus 2c. Y squared is equal to x squared 2 times c, which is c. This is just a normal algebraic equation that you're given. So you can also introduce this constant to be represented with a. So you can just let this constant, which is 2c, to be equal to a. So if 2c is equal to a, it means I can just represent this with the constant a. So therefore, we can have this as y squared is equal to x squared plus a, which is just a constant like that. Remembering that wherever we have got this a, we are going to substitute with 2c, or we are going to find c depending with what you're given later on. But on just separation of variables, that is what you need. So this is just a basic. As you can see, guys, this is just a basic part that you can actually consider to work with. So you're still working, so I need the general solution there. All right, let's consider the second question, still considering or working with the general solution. Let's say we are given on number 2, that is y dy dx is equal to the cos of x. We are given a trigonometric, whatever that you're given, separate. So that is over dx, so you're going to multiply like over 1. So that is y dx, dy, sorry, is equal to the dx multiplies the cos, so that is cos x dx. As we can see, we've got the y and the dy, the dx and the x on its own, so we can integrate both sides. The integral of y, that is already a 1. So you add a 1 in this case, that will be y squared over 2 is equal to, remember from our derivatives, when you differentiated a sine of x, it gave us a cos of x, and we know that integration is the reverse. So if you integrate a cos, it will give you a sine of x. So this is a sine of x plus the constant of integration. So with this, you can even avoid working with a fraction here, multiply by 2, multiply by 2, also multiply by 2. That means we are going to obtain y squared, which is equal to the 2 sine of x plus 2c. And this can be written in terms of a single constant. Let 2c be equal to a. If this is equal to a, therefore, we can have our equation as y squared is equal to 2 sine x plus a. Just like that. We have got our general solution. So you're going to have these guys throughout and so on and so on. What you just need is to make sure you separate variables properly, work with the integral that you are given, your basics of your integrals that you understand. So I'm not going to have much questions, guys. I need us to have another class where we are going to work with question papers. So I'm just going to be fast here. So this is dy dx, all right, cross multiply, that's dx. Why, guys, I'm just focusing with dx each and every time. I do not know why. All right, let's integrate this part. Y, as I said before, you're going to add 1, that's y squared over 2. E remains as e from our derivatives. The derivative with respect to x of e to the exponent of x is equal to e to the exponent of x, remember? So the reverse, which is the integral of this, is just going to be a to the exponent of x plus the constant of integration. Again, I can just remove this 2 by 2 here to remove the numbers affecting there. That's y squared is equal to 2a to the exponent of x plus 2c. So this can be represented with a constant a if we let 2c to be equal to that. That is, this it's you who said let this be. So therefore, y squared is equal to 2a to the exponent of x plus a. So that will be plus a, which is our constant. So this, I want us now to understand what will happen when there is a lien, when we are introducing this, because as you can see on this case, is just a directory, just 2c is equal to a, whatever that you're given. Is it 3c? Is it 4c? Is it 5c? Whatever that you're given, you equate that to a. But there are conditions. One, when you are given, there can be this condition. Let's say you integrate. Okay, let's save the question so that I can explain from the statement that, from the question, I mean, that we are given. We can be given that dy dx is equal to xy. And by separating these variables, we're going to take the power of y. This is same as over 1, cross multiply. Thus dy is equal to xy times dx. All right, so we've taken dx to this side. But there is x and y, which is impossible for us to integrate with respect to x. So we're going to get rid of this y. So how can we remove this? Just simply divide by y both sides. So by dividing, you are obtaining the part of y on its own. That is dy with y is equal to x dx. And be careful, this is 1 over y. This is just like 1 over y dy like this. So we're integrating 1 over y. This is from our basics of our integrals. We know that 1 over x is ln x. 1 over y is ln of y. So this will give us the ln of y if we are to integrate both sides. So that is the ln of y, and this side will be x squared over 2. So this is what I want you to understand. You are supposed to have a constant, which is c like this. But in this case, because you are working with the part of y having a ln on y. So this is affecting the part of y. Whenever you have this, introduce working with the trig, like these are, working with these algebraic expressions, not for a trig, just for algebraic. So on a for algebraic terms or expressions. So this is just in our algebraic part. We do not have any trigonometric like ln, cos, or we do not have that. So what you're going to do is the constant, as we introduced before, we just let the constant be equal to, if it is like that, I'm going to just have a. But this time, because the part of y has a ln, the constant c, you're going to introduce as c is equal to the ln of a. So you're going to let c to be equal to the ln of a. So that in calculations thereafter, if you want to have this a is going to be e to the x, a will be e to the exponent of c. Remember, ln means c is equal to the logarithm of a in base of e. So to remove this, that will be e to the exponent of what? Of c. So in later case, like if you want to have the value of a later on, but in place of c, which is our constant, we are going to substitute the ln so that we can make y the subject. I want you to see what's going to happen there. This is going to be given as the ln of y is equal to x squared over 2. Remember our constant c. We said let it be equal to the ln of a. So this is going to be plus ln of a in place of the c. So that's why you've got a. So in this, we can make y the subject, whatever that you're given. All right, because there is ln and there's also ln, there's a log. So you're going to take this log to another logarithm. So the log of y minus the ln of a is equal to x squared over 2. Remember from our laws of logarithms, subtracting our logarithms means we can divide the numbers that are affecting these logs. So same, if this is a ln and this is a ln, meaning it's going to be ln a over b. We are subtracting same part. So this will be ln y over a, in this case, is equal to x squared over 2. Remember what I said about the removal of this ln. Ln is in the base of e. It's a logarithm in the base of e. Whenever you've got the ln, you're talking of a number that is the ln of x, the log of x in base of e. So whenever you've got a ln like that, it means that's the log of x in base of e. So to have this part affecting x, e will be raised to the answer that you're given here. So that's in this case. If we were to write in terms of a log, we must know that there is a base of e. So what does it mean? It means the whole of this part, which is y over a, the whole of this. That is this part here. Y over a will be equal to, so you're going to take this, y over a is equal to e to the exponent of the answer. That is e to the power of x squared over 2. And then we can make y the subject, just multiply by a, this side that's cancels. So at the end, y is equal to a times e to the exponent of x squared over 2. We have made y the subject of the formula. So you can even formulate y to be the subject of the formula. That's as a general solution in terms of the a. Remember when we introduced this, you can even refer back there and you have that a in terms of what? In terms of c, with a constant. So you can leave that in terms of a for a general solution. So you saw that when working with the ln on y in this case, the constant, you replace it as the ln of a. All right. But this is not the only case, because there we had the ln which was affecting y. So we want to see if this ln was affecting x, what was going to happen? Because this was affecting y. So what will happen if this ln is on x? That is the question. All right. Let us just take an example of this one. I want to quickly have this. Let's say we've got the ln which is affecting x. We have got something like this: x dy dx is equal to y squared. Then you separate, as you can see here, the y is not on y, so you're going to cross multiply as usual. X dy is equal to y squared dx. I have got x and dx here. So to remove this, I'm going to divide this side. So divide by x, divide by x. To remove this y squared, I'm going to divide by y squared, by y squared, so that this will cancel. On this side, the x and the x will cancel. So we are remaining with dy like this over y squared equal to the dx over x. Okay. So this is it. The y squared that we are seeing, same 1 over y squared. 1 over y squared is equal to y to the exponent of minus 2. Remember, from your exponents, that carries a negative exponent. But you're not going to do that on the 1 over x, because I have 1 over x. 1 over x is equal to x to the power minus 1. No. Remember, integration, we can't integrate x to the power of minus 1. Thus, we write it as 1 over x because we consider 1 over x as the ln. So we're going to remain with 1 over x on this side with respect to x. All right. So let's integrate both sides and see what we are going to have at the end. The integral of y to the exponent of a negative 2. Remember, the integral, you have to add 1 on the exponent. So if you add a 1, that is going to be a negative. That's y to the exponent of a negative 1 over negative 1. The new exponent, you divide always by it, which is equal to the integral of 1 over x, which is the ln of x, plus the constant. You were supposed to have the constant of integration like this, guys. This is also we're supposed to have. But we are working this time, the ln, there is a ln on x, which is different from the previous case where we had the ln on 1. This time, the ln is on x. Whenever you have this condition where the ln is affecting x, this is it here. There's a ln there on x. Whenever this condition exists, you take the constant this time to be affected with a ln. How? You take this, the part with the constant, you take it as it is. It remains as it is. Remember previously I was saying a is equal. We're letting the constant, which was our c, to be equal to the ln of a. It was taken as a constant, like c is equal to the ln of a. Then we substitute, guys, I'm the one who is now confusing you guys here. The a that we had, it was the ln of c, I mean, this one that we had. From the c, we're taking it as the ln. But in this case, this is what I want you to take note. When given a constant and the x is having a ln, because we want it to be easier for us for the calculations, the part of x is having a constant here. That is where the constant is. you are going to use the constant with a ln as it is. You are not going to have this a is equal to the ln of c like what we had before. You are going to take this as the ln of c as it is. There is no a is equal to, just introduce a ln. So as you have this ln, also c, take it with a ln. So you're going to understand that you see that this here, 1 over, remember, negative 1 is same as 1 over y like this, but there's a negative here, which is going to be negative 1 over y is equal to. So you understand that once there's a ln and there's a ln, it's easier for you to work these because we do understand that this would simply give us a product of these two, a product of x and c. So it will be ln cx like this. We do not have a part of our a. So in this case, you just take the constant, direct as it is, you just introduce a ln. So let's make y the subject. We can make y the subject. As we can see, this is the same as over 1. We can interchange, guys. This is a fraction. Y is in the denominator. We can just interchange. Y over minus 1 is equal to, also interchange this side. So it will be 1 over the ln of cx. So I need to remove this negative 1, cross multiply, multiply by negative 1. This multiplies here. So meaning to say y is equal to 1 times this, which is simply negative 1 over the ln of cx. Y is the subject. It's easier that way. It's very easier that way. So you see, it's going to depend with your typical exam questions thereafter. Actually, it's going to depend with our typical exam questions. That's why I was saying we need to work with our exam questions, but that's the easier part that you do when working with a ln on x. When working with a ln which is on y, like what we saw before, we take c to be equal to the ln of a in that part. Guys, I just confused you guys in terms of my, see, working with a tired mind, guys, it's actually something else. You work with your mind being tired like this, but let's just hope we are together. We had the last part where C was the ln of A. And this time, when it is the part of X, you are given maybe 1 over y is equal to, then we've got the ln of x, whatever that you have in a constant. You are not going to introduce any part. It's just ln. You just take it as ln of c as it is. But if it is on y, like what we had, maybe it is the ln of y is equal to x plus c. This c here, you take it and replace with the ln of a. That's what I'm explaining, what I'm trying to explain here. The ln of y is equal to x plus the ln of a. Take note. So you have to introduce it as a constant, like c is equal to. All right. So let's hope, guys, I did not miss, I did not confuse you like on the explanation in between of the video there, because, guys, you know, if you're working with a tired mind, tends to be like that. But anyways, let's say we can be given a trig. When given a trig, there's no effect. Just work your trigonometric part as it is. There's no effect. There's a ln or what, okay? So in this case, if I was to introduce, I was going to multiply by this dx to remove this dx here. So by dx by dx. So that means we are having a sec squared y dy, which is equal to 1 over x dx. So that's it. So you can actually separate these. We've separated the part of y on its own, the part of x on its own, then integrate both sides. Remember, integration is just the reverse of our derivatives. Before, you differentiated with respect to x a tan of x, and you're obtaining a sec squared x. What does it mean? The opposite, if you integrate this, you get a tan. So when I see a sec squared, the integral of it is the opposite, which is a tan, from where it was taken from. So the integral of this is a tan. That is the tan of y is equal. What about the integral of 1 over x? Remember I said is the ln of x. plus the constant, because you're working with a trig. There is no effect. Just leave a constant as it is. So for a trig, just ignore that part. Just ignore. Just ignore that part. All right. Now let us just conclude the part of our introductions of I just want us to have a clear understanding here. All right. So like I said, separate of your variables. So in this case, you can even choose to let this cross multiply. So it's going to be xy dy is equal to, so this is over 1, guys. So just like this. So that will be 4 dx. So you're going to separate, that is, you can divide by this x so that we have got x this side, and avoid having a constant on x. As you can see, later on, we can see that there's going to be a linear, because definitely we are now having 1 over x here. As you can see, we are now having 1 over x. So also work with that mind mentality also to analyze like what's going to happen. We can see that there will be a 1 over x, and if we integrate that, that will be a ln. So avoid working with this 4 here. Just put it, divide by 4. I'm not saying it can affect your calculations, no, but it's best that you work with 1 over x here. All right. So here we cancel. That is y over 4 with respect to y is equal to 1 over x with respect to x. This is what you are used to. So you can integrate, guys. Integrate both sides. Integrate both sides. That's a y plus 1. That's 1. We add a 1, so that will be y squared. So this is y squared over, remember, you're supposed to divide by the new exponent, which is 2. But already there is a number in the denominator, which is 4. So it's going to multiply by 4. So that will be y squared over 8. So in this case, we are going to obtain y squared over 8, which is equal to what? Which is equal to the ln of x plus, we are supposed to have a constant, but the fact that the x is having a ln here, the x is having a ln, the constant will also carry a ln. So it is going to be plus the ln of c. So that in our calculations, we're not going to, so meaning to say our constant that we had is now represented by ln c as it is. So meaning to say we can combine this in terms of what? The ln that we are given. So let's combine. Once we have got a ln, we add, meaning to say that's a product of these two under the same ln that we are given, under the same ln, but we have got a product that will be cx under the same ln. So that's it. So to find this, I'm going to multiply by 8 both sides. So that means y squared can be written as 8, the ln of cx in simplest form. So the simplification thereafter, guys, it's actually in your hands. How are you going to simplify these? But what I need us to work with or understand is that when working with a part of x, introduce that as the ln of c. When working with the part of y, which is when, okay, we remove that part, but when working with the part of y, which is the one carrying a ln, the part of the constant, you're going to write it as a constant, but you introduce it to say that let that constant be equal to the ln of a, so that in place of that constant, you substitute the ln of a. There's so many ways that you can have this. So I just want you to work out as many questions. Then from here, we're going to have word problems. After this, I'm going to come out with the word problems of these differential equations so that we formulate from what we had, we formulate the equations, we solve those differential equations after formulating from a word problem.